Assalamualaikum warahmatullahi wabarakatuh. In this opportunity, I would like to present our paper entitled Superhydrophobic Coating Based on Silica, derived from bagasse modified with phenyl trioxysilane and copper as antibacterial agent by Dr. Ing Silviana, Afizani Matusada, Kensi Budi Saputra, Bernadetta Eka Naftalina, Celia Renaldi Kroon, Grace Natali Catherine, Leonardo Subianto, Mayra Eka Nisa, Nisha Ulaya Maktira, Sabitah Dia Azahra, and Yuki Nilendra Fabiansyah. Degradation of material is a common problem we often face. Degradation of material can occur due to materials being exposed to ultraviolet light, oxidation reaction, or others. So, to prevent the material degradation, a coating is typically used. Coating developed has no offense on the links from antibacterial coating, superhydrophobic coating, and superleohydrophobic coating. Modern coating process usually use nanomaterial technology made from silica. Silica is a very popular material used in the production of nanoparticle coating technology, as it's highly available as a natural polymer. Silica also has unisolar glass forming capabilities that can prevent crystallization during cooling and high elastic elongation. Silica coating can also be manufactured from silica sourced from bagasse. Bagasse ash contains very high level of silica, up to 77%. In general, coatings are intended to obtain certain properties from the surface of material. Coating selection is based on its function, adaptability, level of adhesion required, availability, and also price. There are various types of coating techniques such as deep coating technique, spin coating, and also thermal spray coating. The deep coating technique is a coating method where a substrate is deep and withdrawn vertically from the coating solution at a certain speed. While spin coating is a method for depositioning a thin layer by first spreading coating solution onto a substrate. While thermal spray coating is a process in which a material in the form of metal powder or wire is deposited in a liquid state on a surface that has been previously prepared to form a spray layer. In general, wetting and adhesion interaction between water and surface can be classified into two types. First, hydrophobic, and second, hydrophilic interaction. Hydrophobic comes from the words hydro, or water, and phobia, or dislike, a nature that is not able to absorb and accept water. Meanwhile, the word hydrophilic comes from the words hydro, or water, and phil, or light, a property that is able to absorb and interact with water. This paper recommends the use of silica as a coating material. Silica has the potential to be used as a coating material since it has good adhesion and good protective properties and making it possible to resist the diffusion of water vapor, ions, and oxygen to the metal surface. So, silica can protect the metal from the corrosion. This table summarizes the silica source, researchers, method, and silica isolation process result previously carried. This paper recommends the use of bagasse as a source of silica. As you can see, the bagasse can produce silica up to 77%. There are three methods to isolate silica from bagasse. The first method is gas extraction. The second method is co-precipitation. And the third method is solid-liquid extraction. Steps in gas extraction include surgenous bagasse ash production, uptaking sodium silicate, dissolve sodium silicate into the water with stirring, silica slurry preparation, filtering and washing, and also silica preparation. Let's move to the second method. The second method is co-precipitation. The co-precipitation method is a method of synthesizing inorganic compounds based on the deposition of more than one substance together when they pass through their saturation point. Co-precipitation is a promising method because the process uses low temperature and its method requiring shorter time at around 12 hours. This method has so many advantages, such as low temperature condition, short time required, using easily available tools and also material, and also this method can synthesize with flexible. The third method is solid-liquid extraction. Extraction of silica from bagasse can be carried out by a liquid-solid extraction process using an alkaline solution as a solvent. The silica compound that is formed is still in the form of potassium silicate solution. Hence, the solution is added with 1 normality chloride acid, which is used to bind potassium and produce silica.
Besides its simplicity to be isolated, silica is also inert, hydrophilic, has thermal and mechanical stability, and relatively non-swelling in organic solvents when compared to solid organic polymer resins. However, silica also has this advantage since its active sites are only silanol and siloxane functional groups. This disadvantage can be solved by doing surface modification. The main purpose of surface modification is to change the chemical composition of surface. Surface modification is held by changing the hydrogen atom in silanol group into other atoms other than hydrogen. The functional groups at silica gel surface can be modified by impregnation or forming covalent bond. In order to modify the active site, a substance called as modifier is used. An alternative modifier that can be used is phenyl-3-ethoxysilane or VTES. It has 3 hydrolyzed ethoxy functional groups and 1 phenyl functional group that are attached at silicon atom. Phenyl groups added to silicon can improve the elastic and mechanical properties without much variation in density or thermal conductivity. The addition of VTES can also make the distribution of nanoparticles more uniform. There are several modification methods that can be used, such as the spray coating, salt gel, grafting, and plasma treatment method. The spray coating and salt gel method are shown to be simple and effective way, while in grafting method, double bonds and branched nanosilica are covalently grafted to the surface. In plasma treatment, polymer surface properties are improved by applying reactive gases, plasmas. Besides modifying the active sites, another innovation can also be done by adding antibacterial substance. The addition of antibacterial substance aims to kill or prohibit the growth of bacteria. There are abundant research to find the best antibacterial substance. Probably the best and the most widely used antibacterial substance is the cupric ions. Cupric ions have high antibacterial activity and is inexpensive. The results of the review are, first, sugarcane bagasse has not been used optimally. However, the bagasse has a high silica content that can be used to produce a high-quality superhydrophobic and super oleophobic coating, since the silica are stable in various conditions. Second, the addition of VTES to modify the silica gel may improve the elastic, mechanical, and nanoparticles distribution properties of silica gel, which results in increase of the coating superhydrophobicity. The third, the usage of cupric ions as antibacterial agent has many advantages, such as it has high antibacterial power, cheap in price, it has good chemical stability, conductivity, and low toxicity. Therefore, the relatively high silica content in sugarcane bagasse can be used to produce superhydrophobic coatings. Several modification and addition can be applied to improve the properties of the silica gel in order to make the coating superhydrophobic, super oleophobic, and also antibacterial. This is the end of our presentation. Thank you.